Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on voltaic cells. In our last lesson, we learned about different types of secondary cells. We discussed both the nickel-cadmium battery, which is often used in battery-operated tools and portable computers, and the lead storage cell, which is often used in automobiles. We also learned about fuel cells, which carry out combustion reactions by electrochemical means. We reviewed the differences between primary and secondary cells and contrasted electrolytic with voltaic cells. In today's lesson, we are going to talk about the corrosion of metals. We will explain metallic corrosion in terms of redox reactions and talk about the negative effects corrosion can have. We will also discuss different methods to prevent corrosion from happening. Let us get started. What is corrosion? It is the term usually applied to the deterioration of metals by an electrochemical process. Corrosion causes a lot of damage to buildings, bridges, ships, and automobiles. Corroded pieces can break away, and the item that is corroding can lose its structural stability. This can be a huge safety hazard. Students, please get out your notebook and list 5 items that you have seen that were corroding.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. You might have mentioned a bicycle, a metal fence, construction equipment, or some pieces of scrap metal. You might also have mentioned a specific building in your neighborhood, maybe your own house or items within it. All of these answers are correct. Many items made of metal are susceptible to corrosion. Corrosion reactions are redox reactions in which a metal is attacked by some substance in its environment and is converted to an unwanted compound. Most metals oxidize easily at room temperature. If this process is not inhibited, it can be very destructive. However, oxidation can also work in a metal's favor. It can result in the formation of an insulating, protective oxide layer that prevents further oxidation of the metal underneath. Let us look at an example of this. We would expect aluminium metal to oxidize on the basis of its standard reduction potential. However, when this metal is exposed to air, it is stabilized by the formation of a thin protective coating of oxide, or a hydrated form of aluminium oxide on the surface of the metal. Both water and oxygen are unable to get through this protective coating. Therefore, the aluminium is protected from any further corrosion. Magnesium is protected in the same way. Let us look at an example of a metal that does not form this protective layer. Iron. The way iron rusts is one of the most familiar examples of corrosion. While the reactions that occur are very complicated and not completely understood, we do know that oxygen gas and water must be present. The main steps are believed to be as follows. A region of the metal's surface serves as the anode, which is where oxidation occurs. The electrons that are given up by iron reduce the atmospheric oxygen to water at the cathode. Thus, the cathode is another region of the metal surface. This is the overall reaction. We must note that this reaction takes place in an acidic medium, and the hydrogen positive ions are partially supplied by the reaction of atmospheric carbon dioxide with water to form carbonic acid. The iron ions that are formed at the anode are further oxidized by oxygen. This is the equation for that reaction. Therefore, rust is a hydrated form of iron oxide. The amount of water associated with iron oxide varies, though, so we use this formula. We now understand what corrosion is and how it occurs. But what can we do to prevent it? I am sure you remember learning about electroplating several lessons back. Please describe what electroplating is and how it can be used to prevent metal from corroding.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again. We already learned that electroplating is an industrial application of electrolysis. Electroplating involves depositing a thin layer of one type of less active metal onto the surface of another type of more active metal. This thin metal coating can provide a layer of protection for active metals that corrode easily. Cathodic protection also prevents the corrosion of metals. This is accomplished by connecting the metal that you want to protect with another metal that easily corrodes. The more corrodable metal will act as the anode of the electrochemical cell, while the cathode metal remains protected. One more way to prevent corrosion of metals is by painting them. The paint creates a barrier that separates the metal from oxygen, which over time would oxidize the metal. In this lesson, we have learned about the corrosion of metals. We learned what metallic corrosion is in terms of redox reactions. We also explained the negative effects of corrosion, which can be highly dangerous if not attended to. And we learned methods of preventing it. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.